Was this the lesson plan for that particular lesson that I saw?
Yeah.
Okay, great. All right, so it was great to be in that class. I'm glad that I'm seeing, so it's the same class that I've been observing for some time now, and I guess I'm getting a better sense of, or better feel of which students are in there. So it's really cool to see. And I loved your ratio. I thought that the students participated a lot more in this segment of the lesson. And I also love that you had pre-planned like who you would ask questions to, or so it seemed.
Yeah, I've been just going back over like test data and like looking at my kids that I know, like Carlos in the front has definitely kind of just been on the radar.
Yeah.
He's like middling in terms of, he's not failing tests, but he's definitely not, like the more I read through some of like, I've been having them do a lot more like write out answers and like he's getting answers right on the test, but then when I like go over their test corrections now and he goes to make corrections, like he's still missing the idea, and it's definitely like conceptual. So I just wanted to try to hit more of my kids that are working hard but like missing connections, and I'm trying to figure out more like where this connections are being missed.
Yeah, definitely. So that was, I know that was one of your action steps from the last time I observed you, so it was really good to see it carry out, and I'm glad that you also see how that could definitely influence the learning of students who are missing that, like they have that gap in knowledge. So that's really cool. And overall, I just thought it was a good job with cold calling and giving wait time. I remember there's one kid that you called on, and like it was just silent for like 5, 4, and it was fine. Like it wasn't tense. It was just, you know, you gave him wait time, and that's a good thing. I definitely see a lot of like Teach Like a Champion strategies in there. I thought that was good. And so just thinking back to the lesson and what I saw, what was the purpose of showing students images of the hydrocarbons?
Well, it was like 2 reasons. One, I wanted to kind of tie back into polar and non-polar molecules, which we did previously, and I thought it was a good way to get them to start to think a little bit more critically. So we've talked multiple times about the fact that fats and oils are hydrophobic, and they already kind of know that. Whether they've like internalized it, I wasn't sure yet. And I know they kind of, it was clear that they were starting to understand what types of molecules are polar and non-polar, but not why. And like, when it comes to like moving past molecules that are really basic, and hydrocarbons really are pretty basic, but like, even those, they had trouble explaining what it was exactly about a hydrocarbon that made it non-polar. They knew it was because it's a fat, and fats are non-polar, and therefore it must be a non-polar molecule, but why something is non-polar is different. And it's like a continuing, so yesterday, my 5th period classes, and I was combined with Russ's because was out, and the same struggle with her kids, just not understanding what it meant for something to be polar.
Right. And so I think that the slides that you had and the images showing the different models is definitely important. Why do you think we show the different models of the compounds? Like, why did you add that?
I mean, they're actually all just pictures from their book, but I think it was just a matter of like, we talk about it abstractly, but they don't really visualize it, and so I wanted them to see like, exactly what the molecule looks like. Obviously, it's a model of what the molecule looks like, but like this is what we're talking about, and just giving them something that's more concrete than just like saying it's hydrophobic or it's non-polar, but like trying to get them to start to break down the why, right? Because it's and that's been the big struggle and the big conversation is like they're really good at repeating things, and they're good at like reading, well, this is hydrophobic and this is non-polar, but not understanding, you know, and that would be fine in like a regular biology class, but like with the way that questioning is, and they're really struggling with like reading a question and being able to like apply it.
Right.
So if it's different information than they've seen before, being able to still take. So even if I showed them a different molecule, you know, that they would be able to understand that this is gonna be non-polar because of these
Yeah,
things.
so the modeling definitely enhances the learning.
I think it did. Things were a little bit better with second period yesterday when we went back over some things, but I don't know, like, there are times where I'm like, I don't know what else I can physically provide with it.
Okay.
We've done videos so they can see it in different contexts. We watched a video on soluble and insoluble vitamins and
Right.
showed like their compound makeup and like even understanding that even if there's like 2 OHs or an O in a molecule, the vast majority of it is capped with like filled electron shells. Like it's going to be a non-polar molecule because there's just not enough polarity there.
Right. So I'm glad that you said you showed them videos because like I said, I have the headphones because I thought this video would be good. But I don't have speakers, I just have headphones. I already listened to it, but figured you could just take what you want from it. Hopefully it works. I'll give you the big ol'
Nice headphones.
lab style headphones. Okay, hopefully it works.
It's been open for a while, sometimes it needs your green.
Okay, like refresh the screen maybe.
As I've found out multiple times in my classroom.
I think it's like my internet maybe.
That could be too.
Do you want to try it on your computer?
Sure.
All right. Yeah, my internet is down. Okay, it's you go to YouTube and yeah. And what I had typed is how to teach it enantiomers. And scroll down which one it was. It's this one. Here. Or actually, see, my speakers don't work on mine, but if you want to do this with your speaker, that's fine. Yeah.
Model such molecules and enantiomers. And three-dimensional models like these are great for establishing these relationships because you can manipulate them in actual three-dimensional space. So often things like this are represented in textbooks or on a computer screen, which is two-dimensional, and depending on the way they're represented, it can sometimes be not so obvious what the relationships between molecules are. But in this case, we imagine that the carbon atoms which are in the middle are attached to 4 different substituents in each of these molecules, represented by those 4 different colors. Now, those 4 different colors may be individual atoms, like 4 different halogens, for example, or they can just represent 4 different substituents. But as long as they are all 4 different things, then each of these has a mirror image isomer, and we're seeing both of those isomers. If you imagine a mirror that would be positioned between these two, then when either of these molecules looks in that mirror, it sees the other. So these 2 molecules have the same relationship as your hands. Your hands are not superimposed.
Remember you had talked about that in your lesson.
They're similar, of course, but they are not identical. And so that's why we sometimes refer to these molecules as having handedness or chiral, because they have that same relationship. Now, another way to establish that these are not identical is if I pick up one of these and try to superimpose them atom for atom. I can get the red atoms to match up with the yellow ones, but notice that the green and the purple atoms do not match up. Or if I orient this so that the green and purple atoms do coincide and superimpose, now notice that the red and the yellow are not matching up. So no matter how I spin these around, I can't get them to perfectly superimpose. And that's what we mean to say that they are not superimposable. With only one carbon that is chiral, one carbon that has 4 different substituents, that means there's only 2 of these isomers that are possible. If I build a third molecule like this one, instead to necessarily have to be a duplicate of one of these two. And I can test for that superimposability to figure out for this third one which one it matches up with. And I can see I can get the yellow and red atoms to match up when I'm trying over here on the right hand side. But I notice the green and the purple do not match up. So that must mean that these are not identical. And therefore it is identical to this isomer I had on the left.
You can stop right here. Yeah. But I just thought that was good. I'm sure there are others in there though that could be used. I just thought that one was pretty good. So what do you notice about how the teacher reviewed the isomers?
In this section?
And from what we just saw in the video.
I mean, it was pretty repetitive. I would say just taking the time to show them different ways of holding it, to show them how they're mirror images of each other.
And how is this different than what you did in class?
I mean, well, mine was obviously on a screen and much more two-dimensional.
So I would say then, like, just thinking about what you just said, plus what you were saying earlier, I would say for that lesson, I'd give you a push in making the abstract content more concrete. I know that you were trying by using the different diagrams, but definitely making it 3D by having models or manipulatives would definitely be helpful. So that's one of the action steps I would give you.
Okay.
So use manipulatives or even drawing in the carbons to show where the carbons are, like that, like the model that uses the lines that like the sticks moves. And then you can also use manipulative to show the difference between, it was I think enantiomers, and then when we were talking about cis and trans. And then I think the second action step would be to show a video that gives additional ways to understand. Can you just tell me what the action steps are again?
You want me to include manipulatives and models so students can kind of manipulate what they're looking at, and then providing more videos to kind of solidify content and look at it in different ways.
Great. Do you have that? You have access to models and stuff, right?
I'd have to talk to Kenji.
Yeah. So Reimer or Joseph. All right. Cool. Where are you still on biochem? Could this be
Yeah, we'll
implemented?
be on it for a week. at least,
Okay.
yeah. We're doing macromolecules next week, so we have I'm gonna have them work on this that I found the other day, just to kind of have them start looking at different molecules. Kind of, obviously, I was trying to find things that would let them kind of work with it.
Yeah, even, can you go up for a second? Like, even if you were able to get sets from the chemistry teachers,
have
like,
them build it.
yeah, have them build that. That would be great. And then here's, like,
Yep.
this is great. They have the key, they already know what colors they need to put together. I mean, it's simple for us, but like for them, I think that'll definitely enhance the learning. When are you going? I'm not going to be here next week, so I'll probably just look in your lesson plan.
Okay.
But what day would you?
Probably Wednesday or Thursday. Just
Mhm.
looking at what we're kind of mapping out right now. We're trying to do a lab on water quality next week, so depending on how that could go long. And just because of the way my classrooms are, I can't do labs unless it's an 8-day, so it kind of, it's a little less, it makes things more difficult if we go long or there's a struggle on a lab, so.
You know, if you want, you can use the NPR. We can partition it off because it's sectioned off in a 3 classroom.
Yeah, when you're doing a water lab though, it just gets a little bit difficult, and some of the chemicals and stuff that we're using, I don't know if I'm comfortable having those in,
NPR.
yeah, I know we're doing fecal coliform testing.
Oh, yeah.
I don't wanna bring that in the food area, so.
No.
So, and just for some of the labs, like I prefer to keep them in a science lab.
Sure.
But yeah, no, I've talked to Chase about other times that we might need to move it around. But then again, like if I'm in Albine's room one day, it's just a hassle to try to move.
Yeah.
Sometimes it's better just leave the materials and we finish it up. We just wait and wait. But
Okay.
it tends to make things less
Cool. All right. So now that you've made your initial plan in terms of using manipulatives, what so what are what are all the actions that you're going to need to take in order to carry this plan through?
Well, I need to see if we have enough models that I can use with the chemistry team.
Right. And then if there are enough models, what are you going to do next?
Bring them into the class and have them, probably it would be easiest for like the macromolecule construction so they can understand some of the facts and and I think too, like, it's just another opportunity to talk about polarity of molecules, because as you're building glucoses, they're going to see the open holes that are still left on the molecules that are at the end, versus like when they would construct like a fat, an adipose, an unsaturated fat, and they would see that there would be fewer opportunities for electrons and water to come in. So again, just like more opportunities for them to have a deeper understanding of what's happening. So.
Awesome. So what do you do if, so let's think about the practice for a second. So if I'm a student and I don't get it on the screen, how are you going to roll out using manipulatives to me? Like using the actual models.
In terms of like, if they don't get it, I would introduce the models?
Yes.
Or,
So
I mean,
like,
I think that it's just best to plan in and have the models regardless of if they get it or not. Like, I don't think planning to have them just if they don't get it is effective, because it's been very clear, like even when my students seem to be able to like parrot what they see on the screen, like that doesn't mean that they actually are understanding it.
Yeah.
And so I think regardless of how much they seem to comprehend it in the class, like just building in the macromolecules is like the follow-up to the lecture. Either the second half of class is an opportunity for them to like practice building molecules and understanding like what types of things would be possible.
Cool. So how are you going to roll that out to the class? Like how are you going to teach them how to use? I guess my question is like, what's the opener? How will you like introduce this as a follow-up to the previous lesson?
Well, I think you know, if I have manipulatives that I can bring into the class, like we talk about it in the lecture, it would be something that they would put in their notes, and then it would be an issue of like me having a molecule constructed and letting them like pass that around, or 2 or 3 molecules, depending on which class you size, like, so they can look at what these molecules are and how they're constructed, and then like just knowing how, like with my second period class, like size of it and some of the lower students, like things do take longer, so that next class would be like giving them the opportunity to build and develop their own molecules. And I think like this lab especially like would allow them to look at it here and then do what they can to like try to build this and construct it. And I think there's something to be said for them having to struggle through it versus me like showing them, and this is when you get like they can look at the first one, we would do one together, maybe one of the more simple like fat molecules, but then like pushing them to like, now how would you construct this using, you know, these molecules, you know, and having them work through what glucose is, and then how would this come together? And just letting them kind of struggle with it, and me going around and like, if I'm noticing anything huge. But I think too, like we have our posters of the chemical groups, and so having them start to identify what chemical groups they're seeing on different molecules to really solidify, you know, where these things are placed and what we see them in. But yeah, I mean, I think it's just it's a progression, right? So we would talk about it, they would read about it first, they're reading about it this weekend, we're gonna talk about it next week, then I would show them a model, like a 3D model, and then let them kind of try making a simple model, and, you know, walking through that, and then giving them some more difficult you know, amino acids.
Yeah, I think that's a great way of scaffolding it. And so, like I said, since I won't be here most of next week, Tuesday through Wednesday I'm on campus at a professional development.
Okay.
No, Tuesday through Thursday, sorry. Friday I'm going away at surgery, so Monday I'll probably be here, but
Okay.
I can still use my laptop.
Okay.
So when do you think you can send me an upcoming lesson plan, or maybe even this lesson plan with modifications?
Yeah. Russ and I usually sit down on Sundays and kind of hash everything out and
Sure.
see where we're at with both of our classes.
Okay.
So probably Monday morning or Sunday evening, I can
Okay.
get you like a definitive. I know Monday we're going to be doing the water lab.
Okay.
So Monday wouldn't be the day for this class. Anyway, and then.
Mhm.
So yeah, I would guess it's going to be a Wednesday lesson, just based on how long I think this lab will take.
Sure.
But yeah, so I can get it to you by Monday morning at the latest.
Okay, great. So I won't be able to see the lesson, but I'm gonna be very excited to just hear like, how did it go? Like, did the kids like it? Did they get it? Did it, how much did it, I guess, enhance their understanding
Okay.
of it? And I think I especially like it just because it was one of my favorite parts of learning chemistry. So
Okay.
I think this is gonna be really good. Yeah. All right. Awesome.